Very good morning to all of you. I welcome you all for the today's lecture of our subject industrial hydraulics and pneumatic. In the last lecture, we have discussed about the actuator part. Okay, then we have gone for the compressor. Last lecture, after compressor, we have gone for the FRL unit. That is a filter, regulator, and lubricator unit. Okay, now today we'll start with the another topic, that is the piping system. Okay, before proceeding further, just give me confirmation message about the whether my voice presentation, whether everything is okay at your end.
Yes, sir. Audible and visible.
Okay, thank you. We'll proceed. One minute. See, the control and the application of our fluid power. Okay, if you consider our hydraulic as well as pneumatic, both are the part of our fluid power. So it's a controlling and the application of this fluid power would be impossible without a suitable system of the transformation or the transferring the fluid. Okay, so or for taking the fluid. Okay, why I'm taking name of the fluid, because you can consider as a water or oil as well as the air. So in the fluid power controlling system as well as in the fluid power application, uh, we need a system for transferring the fluid from reservoir to your controlling system or to the your actuator. So without suitable type of the that piping system, it is impossible to complete our fluid power system. Getting it? Because we know that we need to transfer the fluid between your reservoir, then power source, and then the point of application. That means your actuator. Getting it? So what are the fluid lines are there? No. So that fluid lines means your piping system. So that fluid lines are used to transfer the your fluid and fitting fluid from your reservoir to the point of application. Okay, so due to that only one should understand piping system also. Okay, and also along with the piping system of that fluid line, fitting also is very important. Okay, that means the pipe fitting or the other fitting parts. So that fittings are used to connect the your fluid line to the your power source. Getting it? And again to connect the power source to your point of application. For that purpose also, fitting lines, pipe fitting and fluid lines are very important. Okay, and in this topic, here we are going to discuss the various types of the pipelines or the fluid lines, I can say, then fittings. Okay, which type of fittings we can use. Okay, that we will discuss. Now basically there are three types of lines normally used, fluid lines. Which are that fluid lines? One is the, here I have mentioned fluid power lines. I have three types. One is the fluid one is the rigid fluid line. Okay, it is called pipe. Then we have the semi rigid, it is called tube, and flexible fluid power line, that is a hoses. Okay, so these are the basically three types of the fluid lines which are normally used in the fluid power application. Okay, once again I am repeating: rigid, then semi rigid, and flexible piping. Okay, these are the three types of the fluid power lines. Okay, and again, the what are the number of factors are there, no, that are to be considered while slitting this piping for any particular fluid power application or that system. That points also we should take into the consideration. Now these factors normally include your type of the fluid, then a required system pressure, and the location of the system also. Getting that points also we should know. Getting it. Again, in that I will give one a small example. For example, heavy duty pipe, okay, that might be used for a large stationary fluid power system, but comparatively lightweight tubing that must be used in aircraft. Getting it. And again, that light duty you can use for the missile system also. Okay, because weight and space are critical factor for application also. So that point also we need to consider. And that third one is that flexible hoses that are required in the installation normally. Okay, where units be free to move related to each other. So for that application you can go for that flexible uh, fluid lines. That means the hoses. Getting it. Now, coming to the materials. Okay, that means the materials which are used for the pipes and the tubes. Okay, so mostly that seamless pipe which are made up of the steel according to the standard or that national standards. Okay, that are used. Seamless steel. The pipes, seamless pipes which are made up of the steel. Okay, again as per the standard that are used for the rigid and permanent connection in various connection connecting construction purpose also. Getting it. And the material for the material, the inner diameter and wall thickness, that are the three actually primary considerations in the selection of the fluid lines, okay, for a particular fluid power system. Okay, now again that internal diameter of the any pipe, or that fluid line, that is also important because it determines how much fluid can pass through the line in a given time period, or you can call it as a rate of flow without the losses of power, okay, due to the your excessive heat or the friction. Okay, that we have to eliminate, and you have to consider you have to calculate the rate of flow. So for that the inner diameter of the line is important. Getting it. And what are the velocity of given flow, no, that is less through the your large opening though than the your the small opening. Okay, now the material. Okay, so which type of material we should use for the pipes and the tubes. Okay, I'm telling about the pipes and tubes, huh? That means the your rigid fluid power line and semi rigid. So there are different metals are used, okay, for these tubes and pipe. From that, the commonly used metal are the steel, then copper is there, then aluminum is there, brass is there, or stainless steel. Because each of these metal, no, or metal has its own distinctiveness. Getting it. And also the advantages and disadvantages in certain application. So we should know this question. Please remember the metal which are used for the pipes and the tubes. Commonly used metal: steel, copper, aluminum, brass, stainless steel. Okay, and for each and every metal, they having its own distinctiveness or its own advantages, disadvantages also for a certain application. Now, considering about the steel, so the pipes and the tubing, no, that are relatively inexpensive and that are used in much of hydraulic and pneumatic system. So the steel is used because because its strength, then it's a suitability for bending and that flanging, then adaptability to the high pressure and temperature. So due to these some
Due to the its own that feature about the steel that is used, because I just have told that because it's a strain, it's a suitability for the bending and flanging, then adaptability to high pressure and temperature. Due to that only steel is used in the pipes and tubing purpose. Okay, and it's a cheap. That means the main advantage is that it's a comparatively low resistance to the your corrosion. Okay, due to that only steel is used. Another material is the copper. Okay, again this pipes and tubing that are some times used for fluid power lines. So copper has its high resistance to the copper. Sorry, corrosion. High resistance to the corrosion. Due to that only, and again the copper can be easily drawn or bent. Okay, due to that feature also this copper is used. Again, along with this, copper have one more feature, that high temperature hardening. Okay, that means a tendency to harden and break due to the stress and vibration. Due to that only copper is used. Then aluminum is another material which is used in the many pipes and tubing purpose. So aluminum has many of the characteristics and the qualities which are required for the fluid power life. Again, along with this, the aluminum has a high resistance to corrosion. Then it can be easily drawn to the bend. In addition to this, it has a outstanding characteristic of the lightweight, because we know that aluminum having the lightweight that feature. Getting it? And aluminum alloy tubing is used in a majority of aircraft fluid power system. Okay, that due to that only we should consider this aluminum again important metal. Then last one is the stainless steel metal. So stainless steel tubing is used in a certain areas of the many aircraft and marine fluid power system. Okay, and as a rule, exposed line, then lines which are subject to the that abrasion or the intense heat, that are made up of the normally that pipes are made up of the stainless steel. Again, this stainless steel having the property of the resistance to the corrosion. Again, stainless steel is easily available in the market, or it is commercially available everywhere. Okay, so these are different materials, but the careful selection and the design of the fluid power lines, no, that is very necessary. That is also important for why this selection of the proper piping system is important, because this if you select proper piping system, then you will get the proper functioning of your entire your pneumatic or hydraulic system or the fluid power system. To that only you should be able to select proper piping system. Okay, whether as per your that application you should select a rigid pipe or rigid out pipe, or you have to go for the tube, that you have to think. And again, depending on your particular that application, you have to choose the material. Okay, at what condition your pipe is going to undertake. Getting it? So these are the different methods. Now I will show the. You can see here I have taken some pictures of pipes. You can see small diameter pipe is there. Then we have this larger diameter pipe. Okay, so these are the different pipes. Here we have the tubes. You can see these are the tubes, and these are the hoses. Okay, these pipes means the rigid fluid line. This is a semi-rigid. This one the flexible. So these different types of pipe system or piping systems are used in the many fluid power application. Then you can see while installation of hydraulic system, we need some hoses. Okay, we have seen these are the hoses. Okay, normally we have observed in many applications. So how to install that different hydraulic hoses? For that, we have some basic rule. Okay, so you can see if we want to connect two parallel horizontal this fitting, that time this we have to go for this sorry, we should not go for this one. We have to go for this one. Okay, this is the proper installation of the hydraulic hoses. Okay, then this is wrong. This one correct. See, this one, this is wrong. This is correct. Then this, you can see if you want to connect straight, then this is correct. The second one. This is wrong. This is correct. You can see. Just observe how one can connect to. You can see element using this transferring pipelines. Okay, and this is a flexible one. Getting it? So along with this fitting, sorry, along with the pipe fitting is also very important. Okay, how you can go for the fittings of the two different elements with the help of the piping. That also very important. That point also we should take into the consideration while transferring or while designing any hydraulic system or the pneumatic system. Okay. So this is about the piping system and fitting. Now let us go to the last point, that is a controlling element of the fluid, pneumatic system. Okay, already see already controlling elements of the hydraulics we have studied in the unit number 2. Same likewise here also the controlling element of the pneumatic we are going to see. And now controlling elements of the pneumatic system is what? Our different ones. Okay, that we will discuss now. Just a minute. System, pneumatic system also require control valves. Okay, for what purpose? To direct and regulate the flow of the air from compressor to the various load devices. That means your actuator or the point where actuation or the point of the application. Okay, so for that purpose we need the control valve. And as we know that in order to control the momentum of the pneumatic actuators, the compressed air has to be regulated, has to be controlled, and has to be reversed with the predetermined sequence also. Okay, so also one has to control the pressure and the flow rate of the working medium, that means your compressed air. For what purpose you have to control the pressure of or the flow rate of the your compressed air? Because to produce the desired level of the force and speed to act to the speed of the actuator. So these are the functions that are achieved with the use of the pneumatic valve. Okay, and we need to control again. We need to convert that pressure energy of the compressed air. Okay, that means you can call it the pneumatic energy. So that pressure energy of the compressed air we need to convert into the mechanical energy. For what purpose? To perform useful work. Getting it? So this function is normally accomplished by the devices, and that devices is known as the our pneumatic actuator. Okay, and like in hydraulic system, pneumatic actuators also use both the pneumatic cylinder and the our real cylinder, air motor. Getting it? That we have studied. And the pneumatic cylinder normally we know that generates the motion in a straight line to perform the work, and this air motor, okay, that generates the rotary motion, okay, or that output motion, rotary output motion to perform the work. Okay, and in this topic control element, so we shall discuss about the principle, then construction, and then operation and application of the various control valves. Okay, getting it? Actuator part already we have studied. Now last basic element of the fluid power, that pneumatic system is the controlling element, and we know that these controlling valves are element with a control valve. Control valve function is to direct and regulate the flow of air from compressor to the various load devices, that means your actuator. Okay, so once again we'll go for the function of air controller. Now see, already we have discussed the functions of control valve which are used in the hydraulic system. Here we are going to discuss about the pneumatic valve. Okay, again these are the control valve. Here pneumatic is not pneumatic. Here it is called air control valve. There in the hydraulic system we were calling it as a hydraulic control valve. Here we have to call air control valve. Getting it? Now first we see here I have highlighted functions of air control valve. So there are different functions are there for this air control valve, but the main function of pneumatic or air control valve are, the first is to start and stop the your pneumatic energy, means your pressure energy. The second is very important, to control the directional flow of the compressor. Now to control this direction flow of compressor, we require direction control, that we know that. And to control the flow rate of the compressor air, we need flow control. Getting it? And to control the pressure rating of the compressor valve, we need a pressure controller. That means similar or like a hydraulic system, for this pneumatic system also we have different direction control, we have different fluid flow control, and we have pressure control also. Okay, DCV, PCV, and FCV, flow control, pressure control, direction control. So whatever we have seen for the hydraulic system, similar types we are going to discuss here. Okay, so these are the, please remember, to control the direction and to regulate means of the flow rate. To regulate the flow means the to control the flow rate, and to control the pressure rating. Getting it? For that purpose, control valve are used. Getting it? Now let us go for the classification of the air control valve, or the types of the air control valve. Okay, we'll discuss this one by one. Okay, so these pneumatic valves can be classified in many ways. So one by one we'll go. The first is the classification based on their main function. Okay, how these air control valves are classified. So the first, according to or based on their main function, one is a direction control, then pressure control, and flow control. In that direction control, again we have the check valve, two-way direction control, four-way direction control. Ways means for the ports. Okay. Then shuttle valve is there, then three-way direction control. So for each and every types of the direction control, we are going to further discuss principle of operation working of this each and every one. Then according to or the based on their construction. Okay, according to our classification based on their construction, air control are classified into three types: poppet or seat type wall, sliding spool type wall is there, and rotary spool type wall are there. See, same type is available for the hydraulic system also, hydraulic controlling wall also. Okay, here also same classification is there. Please remember, because already we have discussed this one. Is it correct? Whether we have discussed these walls, please reply me in the chat box. Whether we have discussed this one in the hydraulic part, classification, construction, working of what walls I have told you here. Whether we have discussed, please repeat. Only one student have given reply. Other students, please give me reply. Whether we have studied all control wall in the hydraulic system, all control. I'm not asking about this one. Whether we have gone controlling element, please tell me yes or no. Whether we have discussed these types of the control wall for hydraulic, whether the same type was there, please reply me. Please reply, be fast. Please reply in the chat box whether we have studied construction operation of the control walls with the same types are available here also. Please reply. Without your reply, I'm not going to start further. Please reply me. I will take names also. Anil Dongre, Vijay Surve, Soham, Rajkumar, Pooja, Suhas, Suyog, Rutuja, Gaurav, Shaneshwar, Abhijit, Bapendra, Viraj, Pramod, I think Pramod has given reply, Balaji, Shivani, Mahesh Bangar, Saurabh. Please reply me in the chat box whether we have studied control elements of the hydraulic system, whether what are the types of the control walls we have seen for the hydraulic, whether same types are present here. Only have to tell me that yes, no. Diksha, then Pratik, Saurabh, Baijan, Rahul Gaikwad, Abhijit, Kunal, please reply me. Be fast. You reply there. Then and then only I will discuss the further part. Otherwise, I am just giving information and you are not listening to me. That is not good. Okay. So based on the our class on their main function, pressure control, and flow control, and based on their construction, puppet wall or seat type wall is called. Okay, then sliding spool type wall is there and rotary spool. And further, okay. Now we are going to focus on this direction control, flow control, and pressure control. Okay. We have already discussed about this puppet wall, sliding spool wall, rotary spool wall. Okay, just we'll go quickly on that also. So first we'll go for the this check wall. Okay. Check wall. So what is main function of check wall? So check wall are the most commonly used wall, and it is the simplest type of the direction control, check wall. Okay, and the main function of this check wall is to allow free flow of compressed air in only one direction. Please remember, check wall function to allow free flow of compressed air in only one direction. Check wall is present for hydraulic system also and pneumatic system also. Again, the second second purpose of the function of the check wall to prevent any flow of compressed air in opposite direction. Getting it? So since check wall block the reverse flow of the fluid, they are also called non-return wall. Please remember, in MCQ based question, it's a symbol. Will be asked for the 1 mark. Okay, standard symbol. And just quickly I will show symbol. Just quick minute. Just a second. There. Let me check. Check wall. See, this is a standard symbol of the check wall. Getting it? See, from this direction, from port A to port B, fluid is allowed to flow from that direction. But if fluid will come from the B port and want to go through this, want to deliver or want to exit from this A, that time it does not give any permission to flow in opposition side. Okay, opposite direction. Okay, so please remember, check wall is allowing free flow of compressed air in only one direction. That direction is this one. Okay, you can see due to the pressure of this compressed air which is flowing inside this wall, to that only that spring will compress. That due to that only fluid will pass through this wall. And if you go by this way, it is not possible to flow in further direction. Okay, so this is standard symbol. Please remember. And due to this only, as check wall block the reverse flow of the fluid, due to that only they are also called non-return wall. Okay, so the check wall, actually this is a simplest type of direction control wall. Okay, and it allows the flow of air in only one direction, but does not allow flow in other direction or opposite direction. Please remember. Okay. Then that comes, we have the pop-up wall. It is called seed type wall. Okay, you can see. So fluid will come from this port A. Getting it? Then it is not possible to flow from this. When that push button will actuate, that time only this spring will compress, and then only this ball will come downward direction due to the compression of the spring, and due to that only what are the compressed air, what are the fluid is going to come from the port A, that will pass through this port and it will exit from this port 2. Getting it? And once push button will be if you take out, that means you can bring its original position. That time spring will take its original position. That means retention will happen. That time ball will stop this wall. Okay, so at normal position, this open wall is closed. Okay, and this is a normal position. When you will actuate or when you will push that button, push button, then and then only the fluid will pass through this port A to port B. This is called the poppet or seat type wall. Okay, here ball is used normally. Here sometimes seat also there. Okay, it is called seat type wall also. Then this is a sliding spool. You can see sliding spool. Okay, this is our what are the rod is there? It is called the spool. And this is a land. Okay, like our piston rod and that piston. Okay, so this is a position number 1. You can see fluid will come inside that cylinder or that your actual that wall from port 2, and at this is position number 1, and fluid will go from this port 1. From 2 fluid will come, and from position that port 1 fluid will go outside. When this wall will take second position, that means this one, that time spool will move in this direction, left side. Getting it? So you can see here wall 1 is closed. Now fluid will come from the wall 2 and it will pass through the, not wall 1, port 2, and fluid will pass through this port 3. This is a second position of the spool. So it is called sliding. We have seen this one. Okay. Once you slide, that time only it will change its position. Getting it? So this is a sliding spool wall and its construction and operation. Getting it? Then this is a rotary spool type wall. You can see rotary. Okay. If you take the position number 1, that time flow will see. You can see which port is connected to which one. See, from port 1, fluid will come inside, and from this port 3, fluid will go outside. Same way, port 2 to port 4, fluid will pass. In the first position, spool position number 1. In the second position, you can see its position is changed. So 1 to 4, it is possible, and this 2 to 3 it is possible. Okay. Now see, whatever your that wall casing is there, no, that will stationary, but your spool will rotate. Okay. And the third position, you can see there is no flow. You can see fluid will come from this one port, but it will not go outside because it is not connected to further any port. Okay, that means there is no flow. Getting it? These are different positions of the spool type. Okay, this is a rotary spool type. Okay, same in detail. We have same discussed same in the hydraulic system also. Okay, poppet type, sliding spool type, rotary. Same here I have mentioned. Getting just a repetition is there. And these 3 types of the wall control are based on their construction. Actually, these walls actually used to actuate your big wall, that is a direction control or other thing. Getting it? Now, firstly, we'll go for the direction control. So air control we have divided based on their main function. We have divided into 3 types: direction control, flow control, and pressure control. So firstly, we'll go for the direction control. Now this direction control again further divided into the 2 by 2 or 2 by 2 means what? 2 port, 2 position. Okay, 2 by 2, 3 by 2, 3 positions. Sorry, 3 ports or 3 ways, and 2 position. 4 by 3, 4 port, 4 ways, and 3 positions. Again, these walls again further you can actuate depend on the what are the you have the method of actuation. No, depend on that you can divide. That means 2 by 2 direction control wall. Again, manual operated. That means the push button and that other things. Okay, solenoid operated is there. Okay, that is electrical operated. Then pilot operated is there. Pilot means what? We have to take the oil to operate the wall. Okay, pilot operated. And again, along with this 2 by 2, 3 by 2, 4 by 3 direction control, we have the check wall, shuttle wall, and quick exhaust wall. Okay, in detail we are discuss further. Okay. You can see what are the walls we are going to see now. Direction control. They have separate methods of actuation for that direction control. Okay, how you can actuate, how you can change its position from position number 1 to 2 or 2 to 1. How you can change. So to actuate that direction control wall, we have different types of or methods of the actuation. In that we have the mechanical, electrical, pneumatic, and pneumatic. So in the mechanical under we have the push button, and it's a standard symbol. You can see this is a push button symbol. Okay, it's a pedal operated or push. You can call pedal operated or pedal actuated. Plunger, you can see it's a standard symbol. It's a roller. Okay, so these 4 are belongs to the mechanical actuation. Mostly this I think push button is used. And solenoid, it is an electrical actuation mechanism. So solenoid operated wall. Okay, so you can see it's the standard symbol is like this. And pneumatic means what? Impulse operated. It's a standard symbol is like this. And if you combine that solenoid and this pneumatic, this is called electro pneumatic. It is it's a standard symbol is like this. So these are different actuation mechanism. Okay. So what are the actuation mechanism we have seen for the hydraulic system? Same actuation mechanism is here. Directly operated into your mechanical. Okay. Again in that pilot, we have whether we have seen pilot. Just pilot means we have to take the to operate. We have to take the another that wall. Okay. And in that we have to take the oil to operate. Just quickly. Okay, manual means the mechanical, that is pedal and all this thing, roller and push button. Okay, and electrical means the solenoid operated. Now, firstly, we'll go for this check wall. See, this is the construction diagram. Okay, I already discussed this one check wall. Okay, see it's a position. Now, again, the check wall having the different types. See. Here we have to retain its orientation position, or here spring is used. Okay, so these are standard symbols which are used to show the check wall. Getting it? Here ball is used. Here seat is there. You can see seat is like this one. Here that triangular section is used. Here different. Okay, rectangle section is there. So these are different types of the check wall. And how to actuate this operate this check wall. Now for that purpose we have this one pilot operated check wall. It is called a pilot, or it is also you can call puppet type wall. Okay, to actuate this one. So you can see here we have the movable puppet. Okay, this is a puppet pressure. From this one flow will come this here. Okay, and to pass this normal blocked flow is there. Here it is not possible to take fluid inside, but flow will come from this one. Okay, and when you operate this movable piston to downward direction, that time the fluid will go from this one. Sorry, actually, that pilot pressure, that means oil you have to take from this one. And due to the pressure of this pilot, you can move this pilot piston in upward direction. That time it will move this movable pilot again upward direction. That means spring will compress, and by compressing that spring, flow will pass from this one to this port. Okay, that time it will open. Normally the check wall is blocked. That means it is closed. So normally it is blocked position. See, this is a standard symbol. Okay, normally it is closed. When you actuate, use the help of pilot operate that puppet or that puppet, no, that time only the flow will pass through this one. Getting it? So this standard symbol of the pilot operated check wall. Please remember, check wall, simple non-written wall, it having this symbol. But it is pilot operated that time, or the puppet type, that time it's a standard symbol is like this. Please remember. Getting it? Now you can see here I have shown some application of the check wall. Okay. So pump suction line. Okay, at the end of the suction line, okay, or that strainer, here check wall is there because we don't allow, no need to allow the flow to pass in reverse direction after stopping that pump. No, so for that purpose here check wall is used. No flow from pump to your reservoir. Okay, see. And for pump delivery also check wall is used, but after the pump you can see the position or that location of the check wall. Okay. So once again I would like to repeat one line. Direction control wall are used to change or to regulate or to direction of the flowing fluid. Getting it? As the name suggests, direction control wall is used to control the direction of the flow in a pneumatic circuit or in a pneumatic system. And we are required to move your actuator in the different direction, and it is actually actuated by supplying the fluid in a different direction. Okay. And we know that 2 by 2 means what? 2 port and 2 position. This is standard symbol of 2x2 direction control valve. The normal position, it is closed. Okay. See, this is closed. Working fluid is this fluid is coming from this one. 2x2 direction control valve. It is also called two-way valve. See, okay. And why we need to need this direction control? You can see here example also I have to lift this load or to move upward and downward direction. We need actuator, getting it, and to lift, to change the direction of the by changing the direction of flow, you can change the motion of your actuator. Okay, to push, if you fluid will come to for the pushing in this direction, load will move downward direction, and if pulling, that means by reverse flow, that means fluid will oil will come sorry, here or here will come from this P port to A. That time the load gets lifted. Okay, so due to that only the direction control is used. And see how the direction control can be classified into different. So 2x2 means what? 2 port 2 position direction control. This symbol, okay, arrow should be unfilled for the pneumatic, getting it? And this is a 3x2, 3 port 2 position. Okay, this is a 2 port and 3 position is 1 2 3, getting it? This is a 4x2, 4 position, 1 2 3 4, and 2 sorry, port and 2 position. Here 4 ports are there and 3, this last one, and 3 4 position. So position number 1, position number 2, and this is third. At center position, there is no flow of the fluid from port 1 to 2. Okay, everything is closed. See, this is position number 1, position number 2. Getting it? These are the standard symbol. But for arrow, symbols are used in pneumatic to show that arrow unfilled. And this method of actuation already we have seen. Location of the direction controller, as we know that between your actuation, that means actuator and pump, direction control is located. It's a 2x2 direction control. You can see fluid will come from P, but it is not allowing in the normal position. 2x2 direction control, it is closed because it is not allowing a fluid to pass from P. P stand for the power supply port, okay, or fluid supply pump port. So fluid will not allow to flow from P to A in the normal position. Okay, but when it you can operate this spool, that means when it will come to this left side, not that time spring will compress, and that time fluid will come from this P and the fluid will go outside from A. You can see this position. This on position you can call or actuated. Okay, so this is a actually whatever the diagram I've shown here, not it's a 2x2 direction control which is spring operated type. Spring, you can see here spring is there, and here both off position, that means this one and this on position of the wall I have shown. Okay, if fluid is coming from the pump, that means the P, and spring moves towards the right, then port P will be connected to this A, getting it? And fluid is supplied from to the your further actuator. This is spool type. Okay, the spring operated. This is spool type 2x2. Okay, and this is standard symbol. This is actually push button is there, so push button operated. Spool type 2x2. Okay, because here spool is used. Okay. Please remember this is standard symbol of 2x2 direction control, but it is a spool type, push operated and spring returned. Okay, due to that only here standard symbol is like this. Then 3/2 direction control. You can see P is the first port. Okay, actually this position number 1 is there. Initial position. P is not connected to A or but A is connected to this P. Sorry, A is connected to the R. That means the reservoir. Okay, but when you push that push button, no, that time this spool will move further in the right direction and P will connect to the A. That time there is no flow from this R. Okay, that means this second position. Getting it? So it's a both position. One is the initial position and this is the actuator. That is second position I have shown. P is closed that time. Actuator position. Sorry. Initially this one and this position. P is connected to this one. Actuated position. This is 3/2 wall. But here you can see this is push button. Due to that only here it is shown. Actually the roller they have shown. Okay. You can see this schematic section you have 3-way 2. That means a 3/2 direction control. This to operate single acting cylinder, that means actuator. How we can use 3/2 direction control you can see here. Okay. To lift that cylinder, that time P should be connected to A. Okay. Then 4/2 direction control. There again spool type, spring return is there. You can see normal position, fluid will pass from P to A and from B to fluid will come to the reservoir. But when it actuates that time, fluid will pass P to A. Sorry, P to B, and fluid will come from A to R. Okay, that means this one actuation position, P to R. Okay, understood or not? See, these are the schematic diagram. Actually, if offline exam will be there, no, that time you need to draw this diagrams. Okay, such diagrams and these symbols also. Normal position. Okay. And when this 4/2 direction control, when it is used to actuate that a single acting cylinder, double acting, that time how it is used at normal position, how it is seen. Here I was shown. Okay, it's actuation position. Then 5/2 direction control, five ports are there at 2 positions. Okay, this is one. 2/2, 3/2, 4/3, then this 4/2 we have seen, 5/2. Okay, please remember this is standard. This is standard symbol of the 4/3 direction control. Okay. See, closed center position. In this position, all ports are closed to each other. You can see all ports are closed to each other. Here, in this position, all okay. Open center position wall it is called. This is closed center position wall. Tandem center position wall. Okay. Please remember this one. Getting it? So these are the direction control. What are the shuttle wall, quick exhaust wall, that we will discuss in the next lecture, and then next lecture we'll discuss pressure and flow control also. Okay. These are actually repetition. What are the walls we have discussed in the for the hydraulic? Same walls are there. Whether understood what are we have discussed? Understood or not? Please tell me. Understood or not? Please reply me in the chat box. Please reply me in the chat box. Understood or not? Okay. Now I request all of you, please write down your roll number in the chat box. Okay. We'll stop here for today's lecture. See you tomorrow. Okay. One more lecture will be, is required to complete this remaining part, and then we'll go for the last chapter. Okay. Thank you. Thank you very much. Please write down your roll number in the chat box.